said, we picked up and started to look at and get an idea of understanding the discriminant. The discriminant is a small part of the quadratic formula. So the discriminant is a small part of the quadratic formula. The quadratic equation is ax squared plus bx plus c. If we are solving a quadratic, then it is equal to 0. The a, b, and c come from each of those terms. So I feel like it's important to tell you that the ax squared term, when we talk about x squared, when we talk about x squared, we are talking about the quadratic term. When we're talking about x squared, we're talking about the quadratic term. When we're talking about x, we're talking about the linear term. And when we reference c, we are referencing the constant. So the x squared is the quadratic, the bx is linear, and the c is your constant. The discriminant is going to tell me both number and nature. So nature means imaginary, real, rational, or irrational. Another way of describing the nature is to talk about the x-intercepts. So over here, we refer to these as the roots. Over here, you refer to them as the x-intercepts. X-intercepts and roots mean the same thing. They are the points that occur when y equals 0. So these are the points that occur when y equals 0. If my discriminant is positive, then I will see two real roots. And those real roots are going to occur at the point when the graph crosses the x-axis. Those real points are going to occur when the graph crosses the x-axis. That is also interpreted as two x-intercepts. So in this case, those roots or x-intercepts are at x equals 1 and x equals -3. And those are the answers we would have gotten if we solved this by factoring. If your discriminant value is 0, so again, if it helps, you could put like a big plus sign here, a big 0 there, then you are going to get one real root, and it will always be rational. And sometimes I will, like this as a double root. Sometimes I call it a repeated root. When the x value is repeated, then you will only see one x-intercept on your graph. And in this case, that x-intercept is at -3. If your discriminant value is negative, then these are two non-real solutions. We identify them as imaginaries. That means my answer will eventually have an I, and it means the graph never crosses the x-axis. So I have no x-intercepts or 0 x-intercepts. All right, that is the graphical analysis. That's what it looks like graphically. Let's do one more problem algebraically, because that's going to be our focus for today. Our focus today is going to be rewriting in standard form. getting bigger, more messy numbers. A lot of the homework problem numbers are easy. You got a lot of zeros. So again, it's really important that we can get this discriminant, because if we can't get a discriminant and we can't simplify square roots, then the quadratic formula is useless. So we're going to rewrite it in standard form. If you forget, standard form is ax squared plus bx plus c. So we always want to get the a, the x, and the b, or the a, the x, and the c all on the same side. It's always got to be equal to 0. And if you have multiple x squareds or multiple x's, you have to combine like terms. So in the case of this problem, I need to add 12 to the other side. Then I need to do or identify my A, B, and C, because I need to know what they are. If I don't know what A is, then how can I plug it into my formula? And again, you don't have to write it down, but if you missed yesterday or you're still confused, A is on x squared. A is always on the quadratic. B is always on the linear. If there is no x term, what do you think my B value is? 0. Good. If there is no x term, my B value is 0. Okay, plugging into b squared minus 4ac gives -2 squared. You need to know that anytime you square a negative, that answer better come out positive. If you're going to put it on your calculator, you have got to wrap the negative in parentheses. Minus 4ac. Okay. 4 minus 2 and 4 gives a negative 200. If you have a negative 200, then what do you know about your solutions? Well, I know that there are 2 of them. It's negative, so they're imaginary. So there are 2 imaginary roots. How many x-intercepts? So that's what we're going to go to next. How many x-intercepts? None. So that's the new part for today. How many x-intercepts? What does that imaginary roots mean? What does the real roots mean? It means